Now, in the wide area network, we had WAN switches. And we called them WAN switches because they were looking at layer 2. Is it frame relay, X25? Is it ATM? Is it, all these things I just talked about, ISDN? And they would switch on those. But they also had routers to get through. Sometimes we call them the provider edge routers, and essentially they had core routers. Modems, as I just talked about, could be synchronous transmissions or asynchronous transmissions. They were the modulator demodulators. Think of the dial-up, the phone network with those. It could have remote access servers that I have to connect to and authenticate before I can get connections. We had channel service units, data service units, CSUs, DSUs. And what they did is they took our traffic. So I said frame relay, as an example, might be something I use in the WAN. And so I send my frame relay information into that WAN cloud. And that WAN switch would see that frame relay, and it would say, huh? It wouldn't know what to do with that. Somewhere between where I sent it and by the time I got to the WAN, it needed to be translated, and that's often what the CSU DSU did. Translated it into a signal that could get through that cloud. We also had multiplexers. People call them muxers. And that's, think about it. If I'm a service provider and I've got a really expensive switch, I don't just have one customer. I got thousands of customers. And we're all going to use the same transmission line to get to where you want to go. That means you all got to take turns. I got to take all your signals and mix them together. Multiplex. We could do it based on time, right? If you're ready, you go. If you miss your turn, you got to wait till the next boat. Asynchronous time multiplexing meant that, you could hop in. If that one went empty, go ahead and go. Frequency division multiplexing, statistical multiplexing. They're just ways of being able to merge these separate signals into one signal to get to another destination that would then demux them and get them all to the right locations. Now, I've talked a lot about WAN technologies. I'm not going to get any more in depth about how they work. The point-to-point protocol is one I haven't talked about, but it comes off of what we call a leased line. The reason they call it a leased line is that it gives us the most security and often the best performance, because technically when my signal hits that line, it goes straight down that line to the endpoint with nothing in between. All right. In the practical world, that's not true, unless it's directly connected. If I'm directly connected, right, if I can physically follow that cable to get to that location, that's great. But in the world of service providers, they still have thousands, if not millions of customers. So they can virtualize that point-to-point protocol, but I guess you really don't need to know about that much. And this is a part of what you're auditing. All right, so what else do we have? X25, predecessor to frame relay. Frame relay was designed for low-speed networks, usually no more than a T1, where I could have different amount of channels to different locations. Integrated Services Digital Network was a step up from the modem. Went from analog to digital all the way through. The ATM was great for low latency. It was really good for video and voice. Today we're seeing Mpls. Now Mpls is cheating because everything else I've talked about has been a layer 2 protocol. They like to say that Mpls is a layer 2.5. It's not quite layer 3. It's not quite layer 2. It's a little additional tag that we put inside of our frames. And we start switching based on those tag numbers, technically called labels. We also have the specifications for DSL, the digital subscriber line. And we have the VPNs, the virtual private networks. Now, for the most part, every VPN you're going to come across is going to be a remote access VPN that involves encryption with encryption technologies called IP security or IPsec. You need to know that you can have internal VPNs, intranet. Nothing says that you have to only use encryption when you're going across the internet. You can have extranet encryption, even if it's going through a service provider. And service providers have their own set of VPNs that you may never even know exist. And you shouldn't. They just put them in there so they can give you a virtual private network. In other words, they don't want your customer traffic getting mixed up with or misunderstood as another customer's traffic. So they have ways of distinguishing traffic and getting it through the networks, but it's still a private network like a virtual one.